Now that we know how matrices are described, we should also know how the elements of a matrix are also described. Generally, the elements of a matrix are described by A subscript I, J, where I is for row and J is for column. So in order for you to know a particular element of a matrix being referred to, you should be able to know the row in which it falls and the column in which it falls. Now let's use this example to explain it. So looking at this example, matrix A equals 1, 7, -2, 6. If we are being asked to identify the elements A11, A11 here means that the element in the first row, first column. First row, first column. So let's see the element we have in the first row, first column. What is our first row? This is our first row. And what do we have as our first column? This is our first column. So the point of intersection of the two is here. So our first row, first column element is 1. Now let's identify A12. A12 means the element in the first row, second column. So we still have our first row as this, but our second column is this. So the point of intersection is here. So it means that our elements in the first row, second column is 7. We can do it for the rest. This one is in the first column, second row. So second row, first column. So this will be A21, and that is -2. We can also do it for this. This one is second row, second column. So A22 is also 6. I hope you've gotten it. Thank you very much. Now let's look at the general way of writing matrices or representing the elements in a matrix. So generally, this is how the elements of matrices are written. We have A11 as explained here. A11 means the element in the first row, first column. A12, first row, second column. A13, first row, third column. The same thing is applied to the rest. The 3 columns here mean that they move up to the expected number of elements. So we have the horizontals and we have the verticals. So this is how the elements of a matrix are written. Having seen the definition, matrix notation, how matrices are described, and how the elements of a matrix are described, we are going to look at the types of matrices. The types of matrices. And the first type that we are going to talk about is a square matrix. What is a square matrix? A square matrix is a type of matrix that has the same number of rows as columns. It means that the number of rows is the same as the number of columns. So we say that rows are equal to columns. So let's look at this example. In matrix P, we have so in this matrix, before we can know that this is a square matrix, we should know the number of rows, the number of columns, and then we check if they are the same. If only they are the same, we say that there is a square matrix. So let's identify our number of rows, our number of columns. So the horizontals, we have one, so one row, one column. So we have one row, another row. So we have 2 rows. So 2 rows. And then when we check the columns, we have column 1, column 2. So we have 2 columns. What is? It can be described as a 2 by 2 matrix. And this makes this particular matrix a square matrix. Why? Because the dimensions are the same. In other words, the number of rows is the same as the number of columns. Let's look at another example. So in this, we should know the number of rows, the number of columns first. So let's quickly look at it. We have one of the rows, row 1, row 2, row 3. So we have 3 rows. Let's check the columns. Column 1, column 2, column 3. So we have 3 columns. So this will be a 3 by 3 matrix. And this one too is a square matrix. Why? Because the dimensions are the same. In other words, the number of rows is the same as the number of columns. The second type that we are going to look at is a rectangular matrix. When we say a rectangular matrix, what does it mean? A matrix is said to be rectangular if the number of rows is not the same as the number of columns. So we say that rows are not equal to columns. So it means the dimensions will not be equal. Let's have this example. In matrix B, let's check the number of rows and the number of columns. After that, we will know whether it is a rectangular matrix or not. So let's check the rows. In the rows, we have the first row to be this. This is the first row. This is the second row. So we have 2 rows. Now let's check the columns. With the columns, we have column 1, column 2, column 3. So we have 3 columns. It means that in this matrix, we will name it a 2 by 3 matrix. Why? Because there are 2 rows and 3 columns. And looking at the description, it is clearly shown that the dimensions are not the same. Let's check. The rows are 2, the columns are 3. They are not the same. As it was stated here, rows are not equal to columns. So if you have any matrix and the matrix is having the number of rows not equal to the number of columns, we say that it is a rectangular matrix. So this is a typical example of a rectangular matrix where rows are not equal to columns. The next type that we are going to look at is a zero matrix. When we say a zero matrix, what does it mean? A matrix is said to be zero if all its elements are zeros. So a typical example is this. of the dimensions, whether it's a square matrix or a rectangular matrix, if only the elements are all zeros, then we say that it is a zero matrix. So a typical example has been shown here. This is an example. This one too is an example. All the elements are zeros. The last type that we are going to look at is a unit or identity matrix. When we say a unit or an identity matrix, what does it mean? A unit or identity matrix is a type of matrix that has the leading diagonal having all its elements to be 1. That is, in the leading diagonal, all the elements there are 1. And then the elements around the leading diagonal are all zeros. Let's use this example for further explanation. Since it is represented by the letter I, let's quickly look at it. I made mention of the word leading diagonal, but some of you didn't get it. Now let's use the example here to explain what the leading diagonal is. So this is the leading diagonal. This is the leading diagonal. And when you check critically, you can see that in a leading diagonal, all the elements are 1. And then around the leading diagonal, any element we see is 0. So this is a typical example of a unit or identity matrix. Now let's look at this. In this one too, let's check the leading diagonal. This is the leading diagonal. And we can clearly see that in the leading diagonal, all the elements are 1. And then around the leading diagonal, all the elements are zeros. So therefore, this one too is a typical example of a unit matrix. This is where you bring today's lesson to an end. We will meet another time for another version or another episode of this topic. Until then, goodbye.